So, yes, the question I want to answer is what kind of explanations are reductive explanations? So we can start with an example that will serve as an illustration. So why is the sky blue? Maybe you know the answer to this question. The standard explanation from physics is that the atmosphere is composed of molecules, small particles, and particles scatter light. And when the particles are small enough, are smaller, and when the size of the particle is negligible compared to the wavelength of the light, you can say that the amount of light that is scattered is given by this formula, which depends on the wavelength. And so lambda here is the wavelength. And as you can see, the intensity of light that is scattered will decrease with wavelengths, which imply that particles will scatter a small wavelengths more than large wavelengths. And blue is among the smallest wavelength that we can see. So this is an explanation for a single particle, but then you can sum for the taking into account the thickness of the atmosphere. You can sum all the contributions and get to a spectrum that correspond to the blueness of the sky. So I take this to be a reductive explanation. I take Marie Kaiser's definition in her book, Reductive Explanation, The Biological Sciences. So the blueness of the sky in this case is explained by low-level factors, which are internal to the sky. So the idea that the sky is composed of molecules, and all this is all the molecules and the scattering events are internal to the sky. And the parts that do the explanations are represented in isolation. And according to Kaiser, these are the three characteristics of a reductive explanation. Represented in isolation, I mean that we explain first by taking only one particle and explaining how it scatters light, and then we aggregate all the contribution. So reductive explanations are often considered causal, and you have this idea that the reductionist idea that eventually the fundamental level does all the causal work. This is an ontological claim. In this talk, I will be more interested in epistemological questions. And what I want to know is if really reductive explanations of this kind are causal. So the notion of a causal explanation was introduced by Wesley Salmon. According to Salmon, explaining is showing how some phenomena, for example, in our case, the blueness of the sky, fit in a causal nexus. And James Woodward has proposed a counterfactual account of explanation that he also called causal. And the idea that explaining is exhibiting a pattern of counterfactual dependence between explanans and explanandum, or identifying factors or conditions such that manipulations or changes in those factors or conditions will produce changes in the outcome being explained. So now that all is in place, we can go back to our example and examine if it corresponds to these ideas. First, we can note that the reductive explanation assumes a connection between high-level descriptions, which are what we want to explain, the blueness of the sky. So high-level descriptions, which are often rooted in common sense, and low-level descriptions, or types of models that will be used for the explanation. In our case, the high-level description is that the connection, well, no, first, the high-level description can be made a little bit more precise. We can say that the atmosphere is a gas with specific high-level characteristics, such as volume, pressure, and that it appears blue in normal daylight. And then we need to connect this to physical models. So we need constitution postulates, such as the idea that a gas is constituted of weakly interacting molecules, that pressure corresponds to this characteristic, and so on. And that blueness corresponds to light of such wavelengths, or a range of wavelengths, and so on. Then, if we have this connection between low level and high level, then we can explain, because the low level models of the atmosphere, together with the laws of physics, predict that the atmosphere appears blue from the Earth in normal daylight. But a first difficulty is that there are many possible configurations of molecules corresponding to a gas with specific high-level characteristics. So this is a multiple realizability. So if I give you a high-level descriptions, you could give me many possible low-level models corresponding to various configurations of the gas. And the explanation implicitly assumes a probability distribution on possible low-level models that could represent a specific configuration of the atmosphere. When we do the statistics, we examine we sum all the contributions. There is such an assumption of that the distribution of particles must be more or less uniform. So the first problem is that the explanation does not provide us one low-level causal story. It provides us a lot of possible low-level causal stories. But maybe this is not a big problem. You could say, well, the explanation hints to a set of possible causal stories. And most of the causal stories in this set will reproduce the phenomena that we want to explain. And we are confident that one of them is realized. And it does not matter which is realized. It doesn't matter which exact configuration of the atmosphere is realized, insofar as any configuration would scatter blue light. But there is a second difficulty, which I want to examine, is that we could wonder whether each of these causal stories taken on its own would explain the high-level phenomena. And I will take Woodward's counterfactual account to examine this. So the idea that of counterfactual dependence, that we could manipulate the variables of a model and change the phenomena to be explained. And then we have the counterfactual. If things were different, then the sky would not be blue. So the fact that things are this way explains that the sky is blue. So in our case, we can start with the model of one particle, the part in isolation model. The parameters of this model, if I just go back 1 minute to yes, you see the parameters of the model are gamma, lambda, and alpha. These are the polarizability of particles, the incoming angle, and the wavelength, or incoming or outgoing angle, and the wavelength. The problem is that none of these are relevant factors. None of these seem to be relevant factors for the reductive explanation. If we take the wavelengths of incoming light, well, we assume that this is part of the context of the explanation, that that we are in normal daylight condition, and so the incoming light is white. But we wouldn't say that this explains why the sky is blue. We wouldn't say, well, the light that comes from the sky is white, therefore the sky is blue. It doesn't seem to be the relevant factor. Maybe particle polarizability would be more relevant. we could wonder if it's really manipulable. So this is specific to Woodward's account of explanation that the variables must be manipulable, and in this case, it's not clear. But maybe other accounts of explanation would not have this problem. But in any case, it doesn't seem relevant alone, because it can be compensated by the number of particles, the thickness of the atmosphere. Basically, the particle polarizability will only change the amount of light that is scattered. What intuitively explains the fact that the sky is blue is the fact that there are particles and that they scatter light of low wavelengths. But these are not manipulable variables of the physical model. And now if we were to construct a bigger model, that would describe a specific configuration of the whole atmosphere, I think we would have the same problem. If we take the number of particles per volume and the polarizability, they seem to be relevant, but they are not variables of the model. In general, a model of classical physics has a fixed number of objects. It's not something that, it's not really a causal variable. It's not something that allows for counterfactual reasoning within the model. It's more like a parameter of the full model. So in some, we have low-level models that describe specific configurations that, well, we could construct such models, and they describe causal relations between variables such as light ray trajectories. But these causal relations do not seem to be what is relevant for the explanation. They do not seem to correspond to the relevant cause of the phenomena, which is simply the fact that there are particles in the sky and the laws of physics. To make the point maybe more clear, we can consider a class of physical models of the atmosphere parameterized by features corresponding to high-level characteristics. So here we have a graph, which is a graph of possible models. Each point in this graph correspond to a low-level model that describes a specific causal history, a specific causal structure of the atmosphere. And so we can see that each physical model taken alone is not relevant for the explanation. What seems to be relevant is the class of models and the high-level characteristics that are model parameters that specify which kind of model we should construct. So in this case, n would represent the number of particles per volume. This is not necessarily an accurate representation, but n could be the number of particles per volume, and v, the volume or the thickness of the atmosphere. And we would have something like that. We could classify models in terms of the color that would result. And the fact that there we have something that seems relevant for the explanation. The fact that sky is blue is explained by the fact that the physical models in the parts that correspond to the high-level characteristics of the sky are models where the outcoming light is blue. So the dependence relation between these high-level parameters seems more relevant to the phenomena, and perhaps these parameters are even manipulable. Perhaps we have a causal dependence, but this graph is not a low-level description of the atmosphere. It's more like a map of possible realizations. Okay. Now, maybe I'm being a bit unfair, because when you read the literature on mechanistic explanations, they do not really claim to explain the phenomena by giving a cause. Mechanicists who say that explaining is giving a mechanism, they claim to exhibit mechanisms, but they do not claim to point to causes of the phenomena. And even Salmon, who introduced the notion of a causal explanation, makes a difference between etiological and constitutive explanations. Roughly, etiological explanation amount to locating the phenomena to be explained in the causal history, whereas constitutive explanation amounts to exhibiting the underlying causal structure of a phenomena. So for example, why did my headache go away? Because I took aspirin, so I give a cause. And it's kind of superficial explanation, well, I would say. And a constitutive explanation would be, why did aspirin relieve my headache? And the explanation would be because aspirin is composed of such molecules and so on. So a response to my worry, to what I've just presented, could be, well, constitutive explanations, of which reductive explanations are an instance, would substitute a high-level causal relation for a deeper one. This is something you can read as well in the literature. The high-level causal relation could be sunlight through atmosphere causes blue light. And the deeper one would be the one given by that I gave at the beginning of this talk. So the idea that constitution brings about a phenomenon, it's not a cause, it brings about a causal relation. Now there are problems for this way of thinking, I think, is that it seems that if we only hint to a deeper explanation, it seems that this deeper explanation does nothing more than filling irrelevant physical details that are specific to one particular realization. But that, just to repeat the point I made before, the whole class of models seems to matter for the explanation. The fact that we generalize, that all models use the same parts in isolation, and that we parameterize models with high-level variables seems to play an important role in the deepness of explanation. And to show this, we only have to imagine what would happen if we were to give completely different story for each possible realization of the atmosphere. Such precise configuration of molecule would have a certain physical deep explanation and another deep explanation. These explanations would not really be deep if all these realizations were producing blueness by mere coincidence. So the fact that all realizations, all models produce blueness in the same way seems to be important. And finally, a problem there still indicate there's still the problem that Salmon still classifies constitutive and etiological explanations as in the same causal categories, but they seem to be very different. The dependence relation between explanans and explanandum involving constitutive explanation is not a causal relation. Rather, the causal relation is what needs to be explained. The explanandum is not an event, it is a causal relation. So if the dependence relation is so different, why classify them as causal explanations? And this threatens the universality of the causal conception of explanations, the idea that all explanations, all scientific explanations would be causal, because here at least we have two very different kinds of explanations. Now, in response, you could say that counterfactual explanations have been extended beyond causal explanations. And so, for example, various authors have claimed that metaphysical or structural explanations are counterfactual explanations as well. So maybe this is the candidate for unified model of explanation. Maybe reductive explanations are not causal in the sense that we would have a causal dependence relation, but they are still counterfactual. So to finish this talk, I will examine this proposal. And the main question, so the idea of counterfactual explanation is, if this were not the case, then this that we want to explain would have been different. Now, what do we need to explain that the sky is blue? We need circumstances. The fact that the atmosphere is a gas with certain characteristics. We need a constitution postulate. The fact that a gas is composed of very small molecules that interact weakly that will give us a class of models, and we need the laws of physics. Maybe we need a bit more, but maybe this is a simplification. Maybe we need idealization, etc. But I will consider these three aspects. So if we have the three, then we can conclude that the sky is blue. And the question is which could be the antecedent of the counterfactual? Which of these three aspects does the explaining? I would say that circumstances seem to be part of what needs to be explained. So it's the background information that we need to make what needs to be explained more precise. Why does a gas of this volume that we call the sky with such characteristics appears blue in daylight conditions? So this is not what explained. Now, concerning laws of physics, well, thinking of alternative laws of physics does not seem required for the explanation. We don't need to say, well, if the laws of physics were such and such, it doesn't, well, maybe these are my intuition, but intuitively speaking, I would say that laws are not the exponents, but rather they concern the dependence relation between exponents and explanandum. And so the best candidate seems to be the constitution postulate. The sky is blue because it is constituted by small molecules. And then the laws of physics gives you the dependence relation between the fact that the sky is composed of small molecules and the fact that it appears blue. But the problem is that if constitution is thought of as a kind of metaphysical necessity in the kind of Kripke's analysis, like water is H2O would be a metaphysical necessity, then a gas has the same constitution in all possible worlds, and so the counterfactual does not really make sense. Another way to say this is that if the dependence relation between explanans and explanandum is nomological, then the explanans must be nomologically contingent. And this would not be the case if constitution is a matter of metaphysical necessity. And if it is an epistemic contingency, well, generally, I think that counterfactual explanations suppose mind-independent possibilities. So in any case, I would say that a unificationist account of explanation makes more sense in this context. So the idea of unificationist account is given by Philip Kitcher, who say that science advances our understanding of nature by showing us how to derive descriptions of many phenomena using the same pattern of derivation again and again. And in demonstrating that, it teaches us how to reduce the number of facts we have to accept as ultimate. And there is a parallel with the notion of parts in isolation, which is a characteristic of reductive explanation given by Marquesa. The idea of parts in isolation is to refer only to those relational properties of wise parts and to those kinds of interaction between them that can be discovered by investigating wise parts in other contexts than in situ. The idea would be that light scattering could be discovered by investigating molecules in other contexts than in the atmosphere. And there, well, I see a parallel between these two ideas, because I would say that reductive explanations unify because the same model, the model of scattering, of light scattering, applies in various contexts, in situ or not. And also there is unification because the sky is blue, whatever its particular microscopic configuration. It does not matter which configuration is realized. We have the sky would be blue. So this is also a kind of unification, and the same constitution postulate the postulate that gases are constituted of molecules can be used to explain a really large amount of phenomena. So the idea that low-level disciplines are interested in less specific objects. Physics is interested in matter in general, not specific kind of objects, but also in more basic kinds of objects. Usually they're interested in small objects, and bigger objects are explained by statistical aggregation, something like that. And in this sense, they provide a kind of unification. So in conclusion, the main idea that I want to put forth is that counterfactual dependence between manipulable variables or causal relations, I would say that they only provide superficial explanations of the kind, my headache went away because I took aspirin. If I only mention the cause, I think it's a superficial explanation. But that in science, these causal relations or these counterfactual dependence relations are more likely to be part of what is explained and not what does the explaining. What we want to explain is all the counterfactual dependence relations that we find by experimentation in the world. And usually these are counterfactual dependence between high-level variables, accessible variables. Well, but this is not what does the explaining. This is what we need, what we want to explain in science, I would say. And that explaining is just unifying various phenomena that can be described in causal or counterfactual terms, is unifying them by a representation by what Kitcher would call patterns of derivation. And that's it. Thank you.